In this video, we want to look at the Haber cycle of magnesium chloride, and then we are going to use that to determine the lattice energy for magnesium chloride. Alright, so how do you draw the Haber cycle? Now the first thing you're going to do is to write the equation for the elements involved in their standard states. So over here you have magnesium in the solid state, and then chlorine gas in the gaseous state. So what we want to make is magnesium chloride in a solid state. Now magnesium chloride is an ionic compound. So the energy change involved in this reaction, if you have solid magnesium and gaseous chlorine to give us magnesium chloride, it is an enthalpy change of formation. So we call it delta HF. So that is the enthalpy change of formation of magnesium chloride. Now for any Haber cycle, the things you need to look at is first the atomization and then the ionization. Now we are going to take the metal first, so let's take magnesium. Now we want to atomize magnesium to make it gas. So if we do that, we are going to have magnesium in a gaseous state. Okay, now we have chlorine gas. Now changing magnesium to its gaseous states involve energy, and that energy is what? That energy is enthalpy of atomization. So we'll call it delta HAT. So that is the enthalpy of atomization of magnesium. Now after we turn it into a gas, the next thing we are going to do is to ionize it. Now magnesium has a valency of 2, and we need to form magnesium chloride. So what do you think is going to happen? The first electron from magnesium, and the energy change involved there is ionization energy, and specifically it is the first ionization energy. So we call it IE1. So that is the first ionization energy for magnesium. Now we actually need +2, so we are going to remove another electron to make it Mg2 plus in a gaseous state again. So we have Mg2 plus. Now in the first process where we remove the electron, so we'll see that we have one electron given out over here. Now this time we have 2 plus, that means we have taken off the second electron. Remember, we have chlorine here, chlorine gas, and this time the electrons that we have are 2. Okay, now we have 2 electrons. The energy change here is the second ionization energy, so we'll call it IE2. So that is the second ionization energy for magnesium. So now we have magnesium in the ionic state. The next thing we need is to get the chlorine in its atomic states. Now so far the chlorine you've been seeing here is Cl2, which is telling us that it is the gaseous chlorine and it is molecular. Okay, it is a molecule. Now we need it to become atoms in order to ionize it. So what is going to happen is we are going to atomize the chlorine. We are going to atomize the chlorines, and then we are going to have Mg2 plus here, and then the chlorine, which is now 2Cl. That means it is an atomic state, and we need 2 of them. So if we're to be only one that we need, then it's going to be half of the enthalpy. By this time we are going to have 2 chlorine atoms plus 2 electrons. Okay, now over here the energy change involved is a enthalpy of atomization of chlorine. So delta HAT, but this time it is for chlorine. Okay. All right, so now what is going to happen next? Now that we have the chlorine in the atomic state, we are going to ionize it. And how we're going to ionize it, we are going to add the electrons to it. The energy we need to add the electron is the electron affinity. Okay, is the electron affinity. Now notice that we have two atoms of chlorine and we are going to add one electron to each of them. Okay, so what is going to happen is we are going to have magnesium 2 plus in a gaseous state, and then we are going to have two chloride anions. Okay, two chloride anions in a gaseous state as well. Now I said the energy here is the electron affinity. Now don't get confused, this is still the first electron affinity because we are dealing with two separate chlorines. For that matter, we are going to multiply it by 2. Okay, if it is just a single atom and we are adding 2 electrons, then we are going to be dealing with first and second electron affinity. But since we have 2 chlorine atoms and we are adding 1 electron to each of the atoms, it is still the first electron affinity, just that we are going to multiply it by 2. All right, now that we have both atoms in a gaseous state and they are ionized, we just need to combine them to form the product. And now the energy we need for that is what is referred to as the lattice energy. So the enthalpy change here, delta H, lat for lattice. All right, so our von Haber cycle is complete. Okay, the von Haber cycle is complete. So we've atomized and then we've ionized the 2 species involved. Now we'll use this to calculate the lattice energy, of magnesium chloride. So we have magnesium chloride, MgCl2. What we are going to do is to add up all this. Now you need to know that lattice energy is equal to standard enthalpy of formation minus delta H1. Now this delta H1 is like a summation of all these energies that we've talked about while we're drawing the diagram. So we are going to add up all of them to form delta H1. So let me put this line here to separate this. So for delta H1, we are going to add up all of this. So we are going to have the enthalpy of atomization of magnesium. Okay, so add this to the first and second ionization energies. Okay, then we'll move on to the atomization of the chlorine. Okay, atomization of the chlorine. Now since we have 2 chlorine atoms, we've atomized it 2, so let me put 2 here. So we need to multiply it by 2, so 2 times the enthalpy of atomization of chlorine. All right, then we'll go ahead and add the electron affinity. So we have 2 times the first electron affinity of chlorine. Okay, now what are the values involved? For the atomization of magnesium, the value is plus. So delta HT, we have the value to be plus 148 plus 148 kilojoules per mole. Now the first ionization energy is plus 736. The second ionization energy is plus 1450. And then we have the enthalpy of atomization of chlorine to be plus 122. Plus 122. Remember, it's going to be times 2. And then we have the electron affinity. So for the first electron affinity of chlorine, it is minus 348 kilojoules per mole. So what we are going to do now is to just put in these values to be able to calculate the lattice energy. All right, so let's work out the delta H1, and then we'll put all of this together. And so for lattice energy is going to be the enthalpy of formation. Now, one more data that I haven't given you is the enthalpy of formation. Now, the enthalpy of formation is minus 641. All right, so let's put all these values into the equation. So enthalpy of formation minus 641 kilojoules per mole, and then we'll go ahead and subtract. So we are subtracting this. Let me put a square bracket here. Now, atomization of magnesium is plus 148. Plus 148. Then I'm going to add this to the first ionization energy, which is plus 736. Plus 736. Second ionization energy. Second ionization energy is 1450, so plus 1450. Then we have the enthalpy of atomization of chlorine. Now that one is 2, so 2 times 122 plus 122, and then 2 times the electron affinity, which is over here. We have minus 348. Minus 348 brackets close, and then the square brackets. Now if we punch all of this in the calculator, we are going to have the delta H to be equal to minus 641, okay, minus plus, that means the summation of this in the square bracket is going to be plus 1882 kilojoules per mole. So if we do the mathematics, then we are going to have minus 2523 kilojoules per mole. All right, so that is a lattice energy of magnesium chloride, and this is how to use the Born-Haber cycle to work out the lattice energy. Thank you.